little bit about quadratic equations. Quadratic equations, first of all, by that what we mean is basically x squared equations. A couple of just examples of quadratic equations. X squared, I believe I was going to do minus 7x minus 18 equals 0. That's a quadratic equation. Y minus 3 equals 6 plus y squared. Another quadratic equation. The distinguishing mark of a quadratic equation is simply that it's a second degree equation, meaning the highest power in your terms is the second power. That's what we mean by quadratic equation. A second degree equation, and basically x squared equations, okay? And you can have other variables, of course, but we're talking x squared equations. We solved linear equations, x to the first power equations. We solved absolute value equations. They all have their different ways that we solve them. So let's talk about one way, anyway, to solve these x squared equations, ones that have a squared term as your highest power. All right. One method, let's just go with the top one there. One method to solving quadratic equations is solve by factoring quadratic equations. One way, sometimes that doesn't always work, but we're talking about factoring here, so that's a good place to talk about this. Because some of these x squared equations you can solve by factoring. Some you can't, but some you can. All right, so let's talk x squared minus 7x minus 18 equals 0. That first one I put up there. All right, well, what hopefully maybe you're thinking there is you see that little trinomial on the left side, and you're thinking factor, right? Looks like I can factor this trinomial using the methods that we've been talking about. Now, one key ingredient is before we factor, this side does need to be 0 to use this method. And the first couple we do, it will be already 0, so that we'll talk about what to do if it's not in a second. Okay, but yeah, how does this trinomial factor over here on the left? Well, it's a trinomial, so it's two binomials. It's x squared, so it's x and x for those two, and then it's minus 18 here. Well, you got minus, so it'd be minus 6 and 3. Reverse it, but you also have 9 and 2, don't you? Which one are we thinking? Minus 9 and 2, isn't it? Because add those together, you got a minus 7. Minus 9 plus 2 gives you a minus 7. So I'm going to put a minus 9 in that slot and a plus 2 in that slot, or vice versa. Okay, now we still have the other side 0, equals 0. Okay, well, what it amounts to here is we're going to take it one step further. You know, before we were just factoring, so we stopped when we factored it. Here, though, we're going to take it one step further, and here's the step further that I'm going to take. Turns out there's a little property called the zero factor property. States that if you have an a times a b, two things multiplied together, equals 0, then either a has to be 0 or b has to equal 0. A has to be 0, B equals 0. Now, if we're just thinking numbers there, that does make sense, doesn't it? If I know this times this gives me 0, then let's say A was 5. Wouldn't b have to be 0 for that to equal 0? 5 times, I mean, if I put any other number there, 5 times any other number is not going to give me 0. It's got to be 0. And vice versa. If b is 10, a has to be 0. So that's the property that we're going to use here. If you have two things multiplied together and they equal 0, one has to equal 0 or the other one has to equal 0. How do we use that? Well, here's our two things equal to 0 multiplied together. So what must happen is either x minus 9, that has to equal 0, or x plus 2, you see, has to equal 0. Now, why would I do that, break that up into the two equations like that? Well, that gives me just very simple equations now, doesn't it? X minus 9 equals 0. You don't even have to do any real solving there. Just add 9 both sides. I guess go through the formality there, but it's going to give me x equals 9. And over here I would subtract 2 and get x equals minus 2, wouldn't I? There's my solution. Turns out this quadratic equation has two answers. In other words, x could be 9 or it could be negative 2. And in both cases it works out this stuff equals 0, whether you plug in 9 or negative 2. Okay? So that's solved by factoring. Okay? Try another one of those on here for size. All right, what about 2x squared plus 3x minus 2? That equals 0. Well, it's a similar deal. You said one side is 0 because we need that for that, but we've got a trinomial, so we go into our factoring mode here. It's 2x squared, so we've got to do 2x and x. For the minus 2, it's minus 2 and 1, or minus 1 and 2 is about the only way to do that. So let's try one of those. I think it's going to work out best if I do the minus 1 and cut to the chase there. I believe it's going to be the minus 1 and the positive 2, because that and that is a 4x. 2x times 2 is 4x, and then minus 1 times x is minus 1x, and that added together, voila, is 3x. With me on that? Okay, so that's our correct factoring. Now what do we do? Well, once we get it factored, then we can set individually factors up equal to 0. So just set the two factors we have separately equal to 0, and then solve those equations we get from there, because those are just linear equations now. Here I'll just add 1 and divide by 2. 1/2, fractional answer, and then over here we get minus 2, so it'd be a negative 2. And so once again, how many answers did we get? 2 answers. Okay. We'll see a pattern with that. I'll talk about it more in just a second. But all right. So that's the basic technique. Now, be aware that the factoring that you use could be any type of factoring. I mean, it could be factoring by grouping. It could be GCF factoring. Could be any of those things that we've done with factoring before. Here's another one. 5z squared minus 30z, those are z's there, equals 0. Okay, well, again, one side 0 there, so we need do need to factor this up. How about that? How about that factor? So it's GCF, isn't it? Always looking for a GCF. We do have a GCF of 5z. Yep, 5 is a common factor, and z is a common factor, so I'm going to do that factoring. What does that leave me? Parentheses z minus 6. Okay? Well, again, I've got two things equal to 0 multiplied, right? So I set those individually equal to 0. 5z, set it equal to 0, and then z minus 6, set that equal to 0. What about the first one? Well, how would I solve it? Divide by 5. So you get z equals 0 divided by 5. Is that something? That's 0. That is 0. And then here we'd add 6 and equals 6. Two answers once again. Yeah, and so this one we have a 0 and a 6. I think the other two we had a positive and a negative, didn't we? So they don't, just how the numbers work out as to what type of answers you get. All right. Now, though, let's think about this. X squared minus 10x plus 11 equals 2. Well, I don't think it does, but even if we tried, it's not, the first step here is not factoring. Do you see why in this problem? The reason I don't factor, first of all, on this one is because one side needs to be 0. Yeah, for that thing to work, setting them equal to two separate equations there, it has to be 0. It can't be 2, it can't be negative 2, it can't be 100, it can't be 1. This side, one side needs to be 0. Has to be 0. For this factoring method to work, that one side has to be 0. And so how do I make that side be 0? I'll subtract 2 off, right? From both sides, so I get x squared minus 10x plus 9 equals 0. Now I'm in good shape. Now I can factor my left-hand side, and that'll get me, we're back to the trinomials, aren't we? X squared, so it's x and x. 9 with minus 10 in the middle. It's 9 and 1, isn't it? It's a positive 9, so how am I going to get a positive 9 with 9 and 1? Both negatives, yeah. Negative 9 and negative 1 is how I'd factor the 9 up. That would give me a negative 10 in the middle, wouldn't it? Add them, get negative 10. Okay, so then we've got, now we can set individually those up to 0. Add 9, so we got x is 9. Add 1, x is 1. There's our two answers once again. All right. Take a look at this one. Make a couple quick points on this one. All right, let's say we've got k squared plus 3k equals 5k squared plus 3k minus 25. All right, so point number 1 is what? One side 0, right? One side needs to be 0. Point number 2, though, is, does it matter which side is 0? No, it doesn't. And in this case, it's probably advisable to have the left side be 0. Here's why. Because I'm going to have to move the k squareds to the same side. And so what that's going to mean is, one of the other, subtract it. If I subtract k squared, that's going to give me a positive k squared over here. If I subtract the 5k squared, that's going to give me a negative k squared. I don't want the, if I can avoid it, I don't want the squared term to be a negative. So I'm saying, let's move these terms to the right. Subtract the k squared and subtract 3k, which will 0 the left-hand side out. With me on that? Okay, so that's what? 5k squared minus 1k squared is 4k squared. And 3k minus 3k is 0, so it goes out, and then the minus 25 is all we have left. 4k squared minus 25. Which brings up the next point. This is another type of factoring, isn't it? How do I factor 4k squared minus 25? It's squares, isn't it? Difference of squares, 2 squared and 5 squared, so yeah. Two binomials, 4k squared is 2k and 2k, and the minus 25, so I'm going to do minus 5 plus 5. Now we've got factors equal to 0, so set those things separately to be 0, equal to 0. Here at add 5, so 2k equals 5, divide by 2, k is 5 halves. Here at subtract 5, so I have 2k equals negative 5, divide by 2, so I have k equals negative 5 halves. In that case, they're the same answer, just opposites of one another. All right. Questions or concerns? Now, let me write this one up here. X cubed minus 6x equals x squared. X cubed minus 6x equals an x squared. Okay, well, is this one a quadratic equation? It's got the x squared, but it has a higher power than that. So no, this is not technically a quadratic equation because it has an x cubed in it. It's a cubic equation, third degree equation. Highest power is 3 on these. However, turns out some cubic equations or third degree equations or even higher powered equations, they too can be solved by this factoring method that we're talking about. And it turns out this one is one where we can solve this similarly to what we've done here with our x squared equations. Okay, well, if I'm going to use factoring, again, on some of these you can, and this one we can. Again, though, what do you think has to be the case that we don't have on this one? Have to have one side to be 0. Yeah. For the factoring method to work, any time you work it, it has to be one side has to be 0. Okay, well, it makes sense. Easiest way to go would be move the x squared. So I'm going to subtract x squared. Now, notice it doesn't really line up with any of the others. However, if I was going to put it, where would I put it to kind of put this in order, if you will? Right here in the middle, isn't it? The x squared should go after the x cubed. So I'm going to subtract x squared and put it in the middle here just to put things in order. Cubed, squared, first power, and then 0 is on the right. So how am I going to use factoring there? What kind of factoring can I do? Well, Gcf factoring first, right? Got a common factor of x. Pull out an x, that'll leave me x squared minus x minus 6. That equals 0. Then my trinomial, I can factor it. Can't I? X squared, so it's x and x, minus 6 with, that'd be minus 1. 3 and 2. And a minus 3 and a positive 2. How's that sound? Well, the factor property extends. If you got 3 things multiplied together, that equals 0. Same thing must be true. Either x equals 0, x minus 3 equals 0, or x plus 2 equals 0. Just set each of the 3 individual factors separately equal to 0. Now, there's no solving there. That's one answer. Here you just have to add 3, x is 3. You have to subtract 2, so x is negative 2. Okay. Now, one other quick little note here before we move on. Notice how many answers I got there. 1, 2, 3. You see a connection between the number of answers and anything about the equation. It was third degree, 1, 2, 3 answers. Second degree, how many answers? 1, 2. Yeah. The degree usually matches the number of answers. Now, sometimes you get the same answer twice, so that that could happen. But yeah, a double solution is called. But yeah, the degree is going to match how many solutions there are. So if you've got a fourth degree, there's four solutions. Just a little quick check there. Any other thoughts or concerns?